So in the previous session, we looked at the various layers, and after that we started writing a code. And in that code, our intention is to design the deep neural network. And only for the training part, we wrote a function that is called as, that's called by this name, MNIST conv, right? We want to build a convolutional, right? So where you can see that we applied everything that we had studied so far to perform the training, and at the end we got the updated weights W1, W5 and W0. So in the next step we have to perform the training part, but before that we need to write some codes, some functions such as let's just check what's the name given. Same name we are supposed to write. Okay, this is my convolutional layer. So inside the convolutional neural network there is one layer called convolution and one more layer called pooling layer. So let's write codes for them. All right, so edit. All right, so now sorry, let's start writing the function by the same name. All right, so this is a function the output is a single value. Let me call it as a y is equal to, this is the function name which we have, of, let us pass two variables, one is x and one is the weight, right? These two should get convolved now. So that's our intention. So we pass two things to this particular function, and the function should return the answer in terms of the convolution. Okay, so first I don't know what is the size. Let me find out the size. Okay, right. So I'll try to find out three things now. So I know that the W will be a filter. X is my function, right? Function is 2-dimensional. W is actually 3-dimensional. So I get three values from W. So that is W rows, my first variable that I'm trying to extract. Then the W columns, and also I will get what I call as a number of filters. All right, so number of filters, these are the three variables I'm trying to get. How do you read this? This is size. Okay, just to apply the size of that W, find the size. That's this. Very similarly, I know that I will read, when I read from the size of X, I'm going to get two parameters. Okay, so that is, I'm going to get X rows, number of rows in X, and the X columns, and the third might come, so you can actually ask it to neglect by just typing this tilde. All right, so this actually means that I'm not bothered what comes after this. All right, so that's the technique. So I don't want them, so I'll simply call size of X. So this reads what the sizes of each of the variables we pass into this function. All right, now I have to decide how many rows will be there in my answer y. So I'll define that y rows, number of rows in y is equal to x row minus w row plus 1. This is what we already have seen. So this is x rows minus w rows plus 1. So many number of rows will be there in this. Similarly, the number of columns I have to calculate using a very similar formula. So that is number of columns in y. I call is it as a y call. Number of columns is equal to number of columns in x sorry, minus W columns plus 1. Right, so we could calculate the size of my y. So create a y now. So initialize with zeros. Y is equal to pre-initializing the values, right? Pre-initializing the size of a particular matrix fastens up the things in MATLAB. That's why. All right. So how many zeros should be created, right? Size equal to y rows, columns is equal to y columns, and how many such pages should be there, equal to the number of filters. Okay, so num of filters. So create and initialize with zeros. This is our first case. Once this is done, in my next step, I'll perform the simple convolution, right? It's a two-dimensional convolution, so I have to use a conv2 inbuilt function, or even you can use the function which we had written earlier. All right, absolutely fine. So I prefer using the built-in because, right, when there is something available, right, built-in, you should use built-in. Otherwise, definitely you can go for loop. So the code which we had written to perform 2D convolution, just to teach the basics, all right, how the things happen internally, just to know that we did that. But other than that, this itself is pretty good. Okay. So in the next step, let's begin, right? So many filters are there, number of filters, so many times the convolution needs to be taken place, right? So it has to take place so many times. I'll start with a for I is equal to, starting from 1 all the way till the number of filters. So many times the convolution will happen. Okay, so many times, right? What I should do first, calculate a result, right? So let's define that. So I'll call it the result as a filter. Filter is equal to, take one filter from there, right? So out of W, which has n number of filters, take one of them. So all the rows, all the columns, and the uh, ith value. Okay, so ith page, you just try to read it. That's your capital W, sorry, filter as of now. So what you do, I know that the filter should be rotated, right? That's why filter is equal to, how do you rotate? Once. So this is ROT90. Use this, repeat this twice. When you repeat this twice, what happens? It gets tilted by 180 degrees. That's what I want. I want a flipping things, right? Flipping operation. That's why. All right. So squeeze it off, sorry, squeeze off the filter. Do this, comma 2, right? Twice. Repeat this. Okay. So do this rotation twice to get this. Now, right, I have a filter, I have the X with me, simply perform the convolution. That's Y of all the rows, all the columns, ith page. Y also should have the similar number of pages, right? Because so many answers will come, right? Is equal to conv2, 2D convolution of, right, X, my first function, the filter which is extracted from the W, and I will specify this as valid. Okay, we know why we are using valid, right? So once this is done, end the for loop as well as end the function. This Y total will go back to the calling function. So that's the first function which we were supposed to write. So I'll say this. Then let me check which is the other function that I'm supposed to write. Okay, I think I need to write another function by the name my polling layer. Okay, so edit, go to my polling layer. So this will open up the polling layer function. So what I'm supposed to do, start with this polling function. The standard way of defining a function is function specify what is output. I'll call it as a y, give the name of the function, and pass the variables here, right? So only one variable come, there is no weight, right? There is no concept of weight for a pooling layer, just pass the input. Okay, so once you pass, now we in this particular what you call concept, we have seen that we are going to use the 2 into 2. We mentioned that we are going to use a 2 into 2 pooling. That's why, right? Just to understand, I'll write a 2 into 2 pooling here. Again, which type of pooling we are going to use? Let me write that. We are going to use, I think the mean is preferred, right? That's what we are going to use. All right. So once again, I'll read the size of x, right? So when x comes into this function, I should know what is the size. So number of rows, x rows, then x columns, then the number of pages, I can say, number of pages, or I think the filter should be more suitable because we understand, right? So many filters were used to get this. So number of filters should be equal to, call the function size of x. So it returns three values: x rows, x columns, and the number of filters. Okay, once I have this, now I create my answer y. So I see that the size is going to reduce, right? So define the appropriate number of rows here. So y is equal to zeros of how many rows? If you remember in the theory part, we discussed that rows will be reduced by 2, columns will also be reduced by 2, but the final result will be same as the number of filters. So this is x uh, rows by 2, comma, x columns by 2. This is equal, the pages will be number of filters. Create so many number of zeros first. Okay, once this is done, start a for loop because calculate every value. So for I is equal to, starting from 1 and go all the way till the number of filters, right? Define filter is equal to, get the filter one by one. So it's ones of 2, right? I create a diagonal matrix, ones of 2. I have to divide this by, how do you take a mean? When I have 1, 1, 1, 1, all the 4 ones in matrix, just see here what I mean. When I create ones of 2, let me check what comes. Ones of, right? I said 2. You see this is 1, 1, 1. I need a mean, right? I need a mean means I should divide this by how much? By 4, right? So ones of 2, I simply divide this by 4. Let's see. See, this is 1 by 4, 1 by 4. That's the mean. So that's why I'm doing this. So in order to find out the mean, what we do, I divide this the filter size by 4 because the size of the filter is 2 into 2. So I will write, so this divided by, right? Just to understand the process, I'll write 2 into 2. Otherwise, definitely it's simply 4. Because there are 4 elements, I am doing this. Just when we read this once again, this code, we should understand why it is 4. Okay. All right. So let's proceed further. In the next step, I get my final answer, right? Even in the polling stage, right? You perform the point by point multiplication, right? And get the answer, right? So for that reason, what we do now, I'll call the answer as the, say, my resulting image is equal to, here also we are doing the convolution itself. Okay, this is a 2D convolution of, right, the x, that's coming in, right? X, all the rows, all the columns, ith page, comma, filter, comma, I'm writing valid. So that gives me the image, right? So I got an image. What I need to convert this image into y now. So y of all the rows, all the columns, ith page should be equal to, I'm extracting from image. The variable image contains the data, but I don't read every value. I will read, right, 1 colon, step size of 2 till the end. Okay, so image of this, comma, so many number of rows, again 1 colon 2 colon end, so many number of columns, because I just want the sizes to be reduced, right? That's why this step is necessary. All right, so I'm done, and I think I need one more end to finish the function. So save this. All right. Okay. So now we have the convolution layer function required as well as the pooling layer function required. Okay. Now, so we'll go to, right. So now we'll do the training and the testing, for which we'll write the main code. So so far whatever functions you have written, one is minstcon, which is uh, the skeleton or the architecture of the deep neural network, which performs the training. Okay, and this needs convolution layer like this code, and it also requires another code, that is this one. Okay, we need all the these are the functions required. Now we'll go to the main code. Okay, so let's, so I'll go for the edit, the test text, sorry, it's a test the function. So I think I put a small, so whatever function I wrote earlier, I am going to test that. So this is my, right. All right, so in order to read, I told that we have a huge data set available, right, in the MNIST website. Okay, so from there I already have downloaded that, and it's actually available, right, inside. I made actually, you see here, I made a new folder called the CNN based digit recognition. This is what is a mini project which we are going to do, right? So wherein we have, I have downloaded this. Okay, so there is, the images are here, the labels are here, but out of which 10,000 I have extracted and kept it over here. Okay, so 10,000 images and 10,000 labels. We can use either 10,000 or this contains the whole 70,000 complete data. Sorry, not 70, 60,000. So 60 plus 10 is 70,000. You can use the anything you can use for training and testing. That's what is okay. So it's there. Now I just have to write a code to read that. So see, this is in a different format. It's not in the standard right imaging format. So it's in ubyte format. Right? So for which we have uh, a MNIST image reading function and the labels reading function. We are going to use them directly. Okay, so it's something like a built-in. Okay, so let's go further. Now I'll call images. I have to read the images. So images is equal to, let's use the load MNIST images function. You see, the requirement is you have to specify where is it existing, right? Where is that file? So the file exists inside the just write the dot represents the current folder. A current folder is CNN based digit recognition. Inside that, go in, right? In this, you have to go inside MNIST data. That's what is the folder you can see here, right? So that's the folder MNIST data. Inside this, I can find out, right, the training and the testing data, right? So I'll go for this. Let's do with the 10,000 data set first, as I told. Later on, we can extend this. All right. So this is forward. Let me copy the names carefully. Okay. So that's where you can find out. That's where we find out the data set. So I do this. Then once I read this, I'll try to make sure that this is of the fixed size, right? So I'll images is equal to, right, reshape. Irrespective of whatever is the shape, I already have designed my deep neural network to take 28 into 28 number of input layers. Sorry, input data points, correct? So I should make sure that this also has the same thing, right? This, it does not exceed that, right? So convert the images you read into this size 28 comma 28. Sorry, just a second. Yeah, okay, there was a number locked, that's why the numbers didn't print. So 28 comma 28. So images 28, convert this image into 28 into 28, and you are not worried about what is the third dimension. Okay, any number of that should be fine for, that's fine. Okay, convert the image into this. So I need the labels also to be read, because which image is what number, right? Because this data contains the handwritten digits, correct? So I should be aware of where is which number is what. So that is the label. So I have to read the labels. So let's read the label using the similar concept. Okay, so this is labels is equal to, I'll use the other function, right? There is another function that is available in our built-in set, that is load MNIST labels. Okay, so let's use it. Load MNIST labels. Okay, you have to specify where is the data. Okay, the data is once again present over here. Okay, so this is, once again, I just have to mention the path. So in the current folder, go inside the MNIST data. Inside that, you find this particular file that is actually consisting of the required labels. Okay, let's see what comes up. Let's just run this quickly. Now what I do, I'll go back, because I just want to run everything over here itself. Right? Yeah, so you can see 10,000 images, right? Images will not be displayed because of the huge size, but I can see this in this thing. So cannot display this because it is too huge, right? That's fine for us, no problem. It says that the size 10,000 images you have, and the labels we can see. You can see the label. First image is digit 8, second image is 3, then 2, then 1, like that. Okay, you have all different things. All right, that is done. So the reading part is done, right? The data set is in the memory of our computer. Right. Now let us start the learning process, right? The training begins now. So we need to define the initial values of the weights. Just recall what we did when we tried to classify the 5 into 5 digits, right? The 5 into 5 uh, digit recognition, if you try to remember, First, we wrote all x values, right? X values were the images we created, right? But now it's not required because huge data needs to be read. That's why, right? We don't do the creation of x like that. We load the data directly. So this is the general first step of any of the classification problem using the deep learning or machine learning techniques. Okay, just remember the flow. You will be able to write the code by yourself. Right. Then remember, right, I want to go for a training means first I need to initialize the weights, right? So define. So W1 is equal to, if you remember W1, this is the input side. I had, right, 9 into 9, 20 such images, right? 20 such data set. This is what was required. So I'll just write a small number, say 1e, right, say -2 into rand n. It's a random number. Random numbers I just want to create. What is the size? 9 rows, 9 columns, 20 such pages, right? Just recall what was the size. Okay, so the size of W1 was 9 into 9 into 20. I create that randomly. I create the weights corresponding. Okay, next is W5. If you remember the diagram or the architecture we designed in the previous class, this is W5 is, right, 100 connections, 2000 various inputs. All right, so what do you do? This has to be equal to, let me create it at a random way. All right, so I'll do 2 into, I create the random numbers of, see the number of outputs to this layer. Outputs to this layer is 100 and the inputs will be 2000. So output comes first, 100 comma 2000. Okay, done. So make it random, do something you want. I'll just put -1, which is again random, into, right, I'll do something more. I'll try to bring more and more randomness here. I'll multiply this with, say, whatever, sqrt, square root function of, say, 6. Okay, then maybe I just want to divide this by square root of how many connections you have, 360, right, plus, right, maybe I use 2000. All right, let's see. This is how I wanted to bring some randomness over here. And let me define another one. So that is W0 equal to, I'll do something very similar. So 2 times, you see the size is different now, right? W0 is output, the weights of your output layer. How many outputs you have? 10 outputs to this layer. So 10, how many inputs? Previous layer has 100 outputs, so 100 inputs to this layer. That's all. Okay. From this number, maybe I'll subtract 1 once again, and I'll multiply square root of 6, divide this by square root of, I'll use something different. So there are 10 outputs and 1. So it's, you see, it's random. I'm just doing something that came in my mind. Okay, so we initialize the weights. Let's check whether this is going to work. Yeah, W1, W0, W1, W5 have been created. You can see that in the workspace. Okay, once this is done, right, read the X and D as required. Okay, so let's read the X now. All right, so X is equal to, from where you are reading the X, it is from the images, right? Images is a variable which contains all 10,000 data. I don't want all 10,000, I just want 8,000, right? So because 8,000 is what I'm in my intention, I just want to train it using 8,000, test it with remaining 2,000. So out of 10,000, I'll read 8,000. So how do I read? It is images of all the rows, all the columns, but I want to read only 8,000 images. So 1 to 8,000, right? Images, right? Read the image number 1 to image number 8,000. This is X. Similarly, I want D, right? So target, right? Desired output from where you get it from the labels. Okay, from the labels, do the same thing, right? You read all the rows, all the columns there. It's not a what you call, it's not a two-dimensional, three-dimensional, only one dimension exists. So you can simply write 1 to 8,000. Okay, let's just check whether this part is fine. Yeah, I can see the labels. Sorry, D and the sorry, X and the label. X is 28 into 28 into 8,000, and the D is equal to 8,000. That's fine, right? All right, let's move further. Now, I will recall what was done earlier, right? Earlier, we used to train, right, the machine using several epochs, isn't it? Right? So start with the epochs. How many epochs you want, right? I think this will learn very quickly. Let's start with a very lesser number, right? So then we'll extend, because this is going to take some time, because this is not a simple problem like the 5 into 5 digits. It's 28 into 28. There are 100 hidden layers and convolution layers. So it's going to take some time, right? Uh, During the training process. So I don't want to keep a bigger number. All right. For epoch equal to, I start from 1, maybe I'll go till, okay, initially I just want to have only 3 epochs and see what's the result. If it's not convincing, then I'll extend, right? So it's going to take time. So I'll display the epoch here itself. So when I type epoch, it means simply it will display what epoch, what is the number of, what's the iteration number. Okay, this is absolutely necessary. Otherwise, we'll be stuck. I said that there are 3 iterations. How many iterations are over, etc. We will never come to know. Okay, we will never come to know what's the number of epoch that's going on. So I just right. So epochs are defined 1 to 3. Right. Take a smaller number of epochs. I want to see what epoch currently running. So I simply write epoch over there, below the inside the for. Okay. So next is, once you define this, call the function, right? Call the function which performs the training. So as a result of training, what are the variables you are going to get? You will get W1, W5, and W0, right? How to know this? How do you know this? Right? Simply come to this minst con. This is the function which I'm going to call. You see, this function results 3 values, W1, W0, W5 is equal to this. Okay, same thing I'm supposed to write now. So this is equal to MNIST conf of, pass the required variables. Okay, W1, W5, W0, pass the input, pass the desired values. You get the weights updated. Okay, once that is done, finish this. Okay, now the training is over, right? Because you already have written a different function for that, right? That will take care of this, right? Now, once the training is over, what is the result, right? What you should do? Okay, let's do one thing. Let's try to save this, right? Whatever variables are there, right? So every variable will try to save it inside a particular mat file. All right, so I'll just write here, save my MNIST dot Okay, just I'll write this. Anyway, you know that it will save, right? By this name. Let's try to run this just to see that whether it's going to run. MNIST con is not found. Yeah, sorry about that. I think it's present outside this, so that's why it's not taking. Let's just copy this. All right, it's here. I just have to paste it inside. All right, now let's try. Let's see whether this is going to run. It's printing out something. Let's see. It's displaying something. Let's see. Let's try to see how to avoid that answer equal to 20 later. Okay. But as of now, there is no error. Uh, Hopefully, the codes we have written is fine. It's continuously displaying something called 2020 20. Let's see. So once the training gets over, you can see that there has to be a mat file created in my current folder with this name. That's what, right? That's the point when we can say that yes, the training is over. So I observe that I gave only 3 epochs, right? Thinking that it's going to take a lot of time, right? I'm expecting at least maybe 5 minutes or something. If training is proper, then we don't have to do the training again. I'll just make it a different block of code after this so that we don't have to run the previous section, right? Again, training is complete now so that we can go for a testing phase. Either I can write a completely different code, right? Saying that, right? The, this code, I can rename it as a train and I can write another code for test. Okay, we'll see. So as we can see here, the my MNIST, that file has been created, MNIST trained.mat has been created. So because of which we can say that the training is over. Okay, so let me check where we are getting that answer is equal to. Somewhere we missed a semicolon. This, you can see that the training is not proper because we put a, we didn't use the proper syntax, right? That's why it's, I think this didn't run 20 times. We have to run again. Now the epochs will, only the epochs will be displayed. You see epoch is equal to 1. Once it finishes epoch 1, it will go to epoch number 2. I think the training is over now and looks fine. So we have the updated values of weights, W naught, rather than what I says. Okay, maybe there is some issue. Okay, during the testing only we'll come to know. Okay, it looks like there is some issue. We may have to increase or decrease this. Let's see what happened with the W1, W5. Oh, everything is not some issue we have. Okay, we'll try to we have to rectify this. Maybe it requires more number, or let's look at the initial value. Let's cut this into pieces and then see. Okay, so in the next step we have to write the code to perform the testing. Okay, so let's do this. I'll create a new section wherein we'll start writing the code required for the testing. So first I need to extract the data required for testing. Anyway, the training is over, right? Training will save that particular file in a given name. Now for testing, right? And write once again, capital X is equal, I'll change my data, right? So I have to read from the images, read them from the images, all the rows, all the columns, but start reading from first 8,000 data already have been read, remaining ones, that is 8,001 till 10,000. So 2,000 data will be read now for testing as a input data. And once again, I'll read the target values. Only I know this, right? Machine is not going to know this. I'm not going to pass this D value to the machine. Okay. It's a labels. Do the same thing. 8,001 to 10,000. So this data, right, is completely new to the machine. Machine does not. All right. Let me create one variable for accuracy. Is equal to, make it 0. Right, as and when machine calculates something right, we'll go ahead and we'll calculate. Okay, so then let me create a the size of, okay, n is equal to, this is length of d, right? That is how many data you are going to test. Okay, once this is done, for j is equal to 1 till, right, how many times you do the testing? N times I do the testing. So for j is equal to 1 to n, small x is equal to, this is the same procedure, x is equal to capital X of all rows, all columns, and jth page. Take one image, right? One image you took, you pass it to the the convolutional neural network, out of which the first layer is the convolution layer. So partial output of the convolution layer, y1 is equal to whatever is the name given, my conv layer. My conv layer, right? To this you pass the input, right? So input is, I think, small x, and there is a weight updated w1, right? You get a y1. Then pass this to the activation function of the convolution layer, which is the ReLU, right? So that's what I'm going to call as y2 is equal to, what's the name of the ReLU? My ReLU of the past layers output, that is y1. I get a y2 now. Okay, once I have a y2, I'll pass this to the pooling layer to get, I think y3 should be name. Y3 is equal to, so pooling layer, that is my pooling layer. To the pooling layer, simply pass this variable y2. Is it okay? Fine. So we got a y3. So I know that pooling layer gives you a lot of pooled values. I need to bring them into the same size as y3. Convert this into a single, multiple pages of document should be brought into a single page. So perform what is called as a reshape. All right. So that is, I'm going to call it as a say y4 is equal to reshape. Which one? Your previous output, that is y3, comma, I'm not bothered about this size, but the second one should be 1. Okay, like this. Then get a partial output V5 that is equal to, you see, you are going to pass this to the next layer containing weights equal to W5. So W5 into, multiply W5 into the past one, that is Y4. Okay, so get a V5, convert V5 into Y5 by passing this through I think I have to use a ReLU layer here. Yes, it's a layer ReLU. Okay, so Y5 is equal to my ReLU of V5 should be fine. Okay, once we have this, I'll get my final output, final partial output, that is V. Okay, V is equal to, pass this Y5 through the final weights, that is W0, multiply this W0 into uh, Y5. So once you have this, calculate a final output. Y is equal to softmax layer. So the function we had written by ourselves was my softmax. Okay, and capital. My softmax of V to get an output. All right. So we have so many y's coming up. There are 10 values of y's will come, right? Out of which I have to take, right, which is the highest one, because the data belongs to that class. So how do you decide that, right? Do this. So don't worry about what comes first. Just find out what is the I value. Okay, this is equal to, I get an I value from this, that gives you the maximum value for the y. Out of 10 values of y1, y2, y3 up to y10, whichever gets you that maximum value, I'll take it into I, right? If, now I'll check if this I equals to, right, see d of j, right, I is equal to 5, say d of that particular j is also 5, means it is a correct classification, right? That's why I'm comparing. If this is right, right, do what, increment acc plus equal to, acc is equal to acc, I think not acc, I think the word accuracy, accu, so accuracy plus equal to 1, accuracy is equal to accuracy, I increment this. All right, so that if condition I end, and also I think I have a for loop that also I'll try to end. Then accuracy, actual accuracy I'm calculating. So this ACC is equal to ACCU divided by n. Okay, multiply that with 100 to get a percentage. All right, I'll just save this. Right, I'll get an accuracy directly using this step. Okay, anyway, right, we already have trained, right? Though the training was not perfect, let's see whether this code runs first. All right, the code runs, then that means, okay, so ACC, ACCU is equal to plus. Yeah, it runs with an accuracy of 10%. Okay, so code runs, no issue with the code, right? We just have to find out, is there any way, right? Is there any other method because of which we can improve this performance?